Limit is y goes to 0 of 2y sine 5y divided by secant y tangent y. The first thing we're going to do is try plugging a 0 in for each of the y's. That'll give us 2 times 0 times the sine of 5 times 0 divided by the secant of 0 times the tangent of 0. 2 times 0 is 0. Sine of 5 times 0 is 0. Divided by the secant of 0, which is 1 over the cosine of 0, which is 1 over 1, which is a 1, times the tangent of 0, which is sine of 0 over cosine of 0. Sine of 0 is a 0, cosine of 0 is a 1, 0 over 1 is a 0. In the numerator, sine of 0 is a 0. So we have 0 times 0 over 1 times 0, 0 times 0 is 0, 1 times 0 is 0, and we have the 0 over 0 indeterminate form. Since this is resulting from trig functions with different phases and power functions, we're going to make use of the identity that limit as theta goes to 0 of sine of theta over theta equals limit as theta goes to 0 of theta over sine theta. It can be either version, and it's equal to a 1. The first thing we're going to need to do is rewrite any non-sine cosine functions into sines and cosines. We don't have any of those in the numerator, so we will have 2y times the sine of 5y in the numerator. But in the denominator, we have a secant of y, which is 1 over the cosine of y. And we have a tangent of y, which is the sine of y over the cosine of y. Our next step will be to take the denominator fractions and reciprocate them and multiply them with the numerator. So we have 2y sine of 5y times the reciprocal of the first fraction, which will be cosine of y over 1, and the reciprocal of the second fraction, which will be cosine of y divided by sine of y. We can put the first expression over a 1 to make it be a fraction so we can multiply all the numerators and denominators. So multiplying the numerators, we will have a 2y, a sine of 5y, and a cosine squared y, all multiplying each other, divided by in the denominator 1 times a sine of y. Now we still have the 0 over 0 indeterminate form. That hasn't changed just yet and won't change until we make use of the identities. To make use of the identities, we have to isolate all of the sine functions, and that's going to be our next step. So we have limit as y goes to 0 of. We have a sine 5y in the numerator. We will isolate that into its own fraction in the numerator. We have a sine of y in the denominator. We will isolate that into its own fraction in the denominator. And then any remaining terms we will write in their own fractions. So that'll be a 2y and a cosine squared of y, all in their own fraction. They're in the numerator. The next step is the phase match. We phase match the sign with the other position. So we have a sine of phase 5y in the numerator. We need a 5y in the denominator. To compensate, we will put a 5y in the numerator of the other fraction. We also have a sine phase y in the denominator. We need a y in the numerator. To compensate, we will put a y in the denominator of the other fraction. Now that y in the denominator of the other fraction can cancel with one of the y's, not both of them. They're multiplying each other, just one of them. We will cancel out with the y in the denominator. Let's rewrite what we have. Limit as y goes to 0 of sine of 5y over 5y, y over sine y, and then 5y times 2, which is 10y cosine squared of y. And that would be over a 1, so we don't need to write that. The first two fractions are perfect identity. We've phase matched them. So that first one will be a 1. That second one will be a 1. And we've removed the 0 over 0 indeterminate form. We can now plug a 0 into the remaining y's, and that will give us 1 times 1 times 10 times 0 times the cosine of 0, and then square that result. That's what it means to be cos squared. It means take the cosine first and then square the result. So we have 1 times 10, which is 10, times a 0. And then the cosine of 0 is a 1, so 1 squared. 10 times 0 is 0. 1 squared is a 1. 0 times 1 comes out to 0.